Hello everyone. Picking up from where we left off, let's dive into turboshaft and lubricating system. To remove the shaft from the housing, compressor wheel is needed to be taken off. It is left-hand threaded, so you need to crack it to clockwise. Next one is a compressor backplate. The compressor backplate serves three main functions: isolating engine oil from the intake housing, securing internal thrust components, and guiding the compressed airflow. Just gently tap it off to break the seal. This is a mating surface of the backplate. This is internal parts of compressor wheel side. Let's clean the parts before taking apart. These are compressor wheel side oil seals. It prevents oil leak to compressor wheel under boost pressure. Turbo oil seals work like piston rings. So correct ring gap positioning is essential during installation, as thermal expansion closes these gaps under heat. Proper engine warm-up is crucial. This is called as thrust collar or oil deflector sleeve. This is not connected directly to the shaft. However, it spins with the shaft to repel oil via centrifugal force. A thrust bearing sticks to the center housing by 3 bolts. A thrust bearing absorbs the thrust loads caused by pressure differentials, and maintains correct shaft clearance to prevent housing contact. This is an oil feeding hole to the thrust bearing. Need to push the shaft down to remove it. It's slightly stuck. This is an oil seal of turbine side. As you can see, here's only one seal. Because exhaust pressure is higher than boost pressure, only one seal is enough to prevent oil leak. Let's see the difference between turbine and compressor side. We can see the carbon buildup on turbine side, as turbine is exposed to high temperature exhaust gas. Turning off engine without cooling down causes burning oil. So, keeping 1 or 2 minutes of idle time is essential after driving. But no more than that. The thrust bearing is directional. Otherwise, incorrect installation causes damage of turbo. This side towards compressor wheel side. This side towards turbine side, as you can see the oil feeding. This hole is for oil feeding to the thrust bearing. I am spraying brake cleaner into the oil feeding hole. The brake cleaner comes out of the tiny holes each side. Pressurized oil from the holes maintains correct shaft clearance. If the turbo has too much axial movement, thrust bearing damage should be considered. This is a journal bearing with a shim. It absorbs radial loads and maintains proper radial clearance to prevent the shaft from vibrating or seizing at ultra-high RPMs. There are 2 journal bearing inside this turbocharger. This one is for compressor wheel side. This is located between the thrust collar and a snap ring in the center housing. Once the oil pressure from the feeding line is applied, the oil goes to journal bearing and thrust bearing through holes to maintain clearance and lubrication. This is the turbine side journal bearing. This bearing is located between 2 snap rings. There's a shim behind the outer snap ring. This is the turbine side journal bearing. Before looking into the turbo lubricating system, let's have a look over the oil flow in the turbo. First, pressurized oil is supplied from the oil feeding line. It goes to the two journal bearings and the thrust bearing. These oil pressure maintain thrust and axial clearance between the shaft and bearings. After this stage, the lubricating oil loses its pressure and goes to an oil sump through a turbo drain pipe. Please remember that I said the oil will lose its pressure after passing the bearing. When you found the oil leak from compressor wheel or turbine, you must identify what the source of this oil leak is. Is there negative boost pressure applied to? Or negative back pressure? Or too much crankcase pressure? Before replacing turbo due to oil leak, you must check these things out to save money. Also, regular engine oil and oil filter exchange is very important. Turbo lubricating oil system has very tiny passages. Even small particle can damage the system. You can see the two holes from oil feeding lines. One passage connects to the turbine side journal bearing. Another side connects to the thrust and other journal bearing. This is a rubber O-ring between the center housing and backplate. If this one is damaged, you can see oil leak from the gap of two parts. These are the components of the turbo shaft. Due to the clearance between the shaft and journal bearings, you might feel free play when wiggle the compressor wheel. So, this is normal free play. But this is too much. Check for damaged shaft. Turbine side journal bearing has carbon deposit, so you might not feel the free play even clearance is out of spec. Lastly, let's check the material of each turbo components. The compressor housing is aluminium. The backplate is iron. The shaft is also iron. This turbo center housing is iron as well. The turbine is aluminium. And the compressor wheel as well. So far, we've covered the internal components of the turbo and its lubrication system. Understanding the structure and function of each part makes troubleshooting much easier. I hope you to enjoy this video. Thank you for watching. I'll see you in the next video.